happening is the market's changing. Customers are demanding more precision and higher quality parts. So it used to be that the PM process would produce a net shaped part and eliminate, say, a hobbing or turning operation that normally was a lot of material waste. So PM took that step, and now with the increase in demand from customers, we have to take it even further with the latest technological advancements, which include materials and machining.
If a company is able to offer them a finished part or a finished part with the addition of another part, so be joined, it's saving them shipping costs and lag in time of the product being shipped to multiple locations and so on. So if you can be creative enough to include all those things, that would be intriguing to a customer.
Virtually anything that you can do to machine a part, we do. And I think that's what makes us somewhat unique in the industry.
So our manufacturing group has spent a lot of time developing parts that not only have properties that customers want, like heat-treated materials, but doing them inside the scope of our manufacturing operation using special materials and new operations to achieve what customers want, which is high precision technical parts. What we have here is a particular part that we've now integrated into our system, our cell here in the manufacturing facility. Rather than using a single machine to do a single operation, we're using a cell to do multiple operations. We have 4 machines behind me here, all of which are hard turning centers. We do a rough cut that takes off the bulk of the material. We then do a fine cut that brings us into a tolerance that's acceptable for putting on a grinder. And then we take it to the last step, which is grind it and do an assembly, a quick assembly process on it, where we just put in a rivet and a second part.
Machining powder metal is not the same as machining steel. You have to imagine that what it is it's a continually interrupted cut. In machining and turning, for example, an interrupted cut is when you have a hard particle, a gap, and then another particle. In powder metal, your part is made of particles that are basically together with gaps, little gaps in between, those little spaces in between the particles. So effectively, you've got continuous gaps. So you're hit hard, hit soft, hit hard, hit soft, and that's what breaks down inserts. And getting the right insert, getting the right speed and feed is very important to the process. Something that we think we're pretty good at. We've gotten there.
There will also be examples of to save them cost, machining in the green state. That is advancing in stages now, where instead of just turning, you can do drilling, you can do many operations now in the green state.
That's prior to sintering, so the tool life is exponentially increased on the tool. You may not gain a lot in terms of throughput, but you'll gain so much in tool life that you're able to offer a reduction in cost to the customer. And not only that, you make it a little easier to manufacture. You take out that variable, because every time you change a tool or an insert, you have the opportunity to change dimension, throw up a burr. There's always those offsets that need to be set.
So some of the things that we're doing on the tooling side, on the processing side, on the material side, blending those all together and using everybody's input to come up with, okay, we think this would be the best solution. Is it always the least expensive part? The answer generally is not always, but it's cheaper as an overall package. So when you do look at quality, cost, and delivery, a lot of those things are impacted with all that teamwork that's gone into it.
The customer looks for the best cost, best quality. And that's standard in the industry. Everybody looks for that combination. I mean, when you buy a car, you go out and buy a car, you're looking for the best quality, best cost, and best performance. We can offer all three.